So let's answer the quite simple question of how many trig functions are there. Now, I'll admit it, this video was actually originally going to be about how we get the trig functions through the unit circle, but it ended up with me discovering so many trig functions. Now, if you're a normie in math, then you'll easily say that there are three of them. Come on, I mean, how could there not be three? It's like, you got sine theta, you've got your cosine theta, and then you've got your tan theta. That's a 1, 2, 3. Let's see, so simple. But you see here, maybe you've taken, this is the ones under calculator and everything. Come on, I mean, so easy. Let's just end it now. But wait, if you've probably taken like a calculus class, you've probably actually heard of some additional ones. You've probably heard of a couple new ones, like you've heard of cosecant theta. You've probably heard of secant theta. Let me just find a good color for well. That's a good enough color. Secant theta, and you've also then heard of like cotangent theta. I think it's like cot, right? Cotangent theta, and and you've taken a calculus text. You say this is it. There's 6 of them, but you see here there are so many more of them, and it's okay if you don't know them. Like it's really, I mean it. Like it's fine if you don't know them. I mean, come on. You probably haven't even been taught so many of them. But let's first, we can. So, if you just Google it on here, I found on a website called John D. Cook Consulting that there are at least 12. Yes. How fun. Let's look at some. How fun. Let's look at some of these beautiful 12 of them. Well, the first one we have is going to be versine. Gotta love versine. That's gonna equal 2 sine squared times theta over 2. So useful. How incredible! I'm sure you'll encounter this one quite often. You've also got we've also got x secant. This one's equal to. I mean, like, come on. I mean, like, how have you never used these two? I mean, come on. I mean, like, you've even got more fun ones. Like, I bet you never heard of haversine. You better heard of have a cosine. Cosine. Maybe you've heard of. Maybe you've heard of x cosine. And yeah, I mean, look, we got 1, 2, 3, 4, 5. Well then, oh my god, there was 1 there. My god, that's horrible. Exocosecant, and finally we also, and yep, we have haversine, coversine, have a cosversine, exosecant, and xsecant, and wow. Look at all the ones we now have here. We have 5 new ones. Bet they're all gonna be so useful here. And there's actually a little rule you can do here, and actually what's one out? Cosine. But you didn't really want to know that one. Bet you so needed to know these ones. And now then, you must be panicking right now, thinking here that there are so many more functions than you could ever imagine here. And what do all these new ones mean? What's a haversine? What does ver even mean? What do these things mean? Well, the first thing is that the ha prefix is going to mean half. You see this one, like, so for instance, this is basically means that we're going to be taking, like, a halfpenny is half a penny. So basically we're going to be looking at 1/2 of whatever we're going to be looking at 1/2 of the function, 1/2 of secant, 1/2 of sine. Sure, it's going to be so useful here. You got it. You got your x is going to be subtract 1. X secant is secant theta minus 1. And then you've also got ver is going to be minus 1 of the cosine. So, when I wrote this 2 sine squared theta, yeah, I mean that is one way you can express it, but really you probably are instead going to want to you could probably write this one out as 1 minus cosine theta. So wow, how much more simple, how simple. Better get started to memorizing all your ver, ha, and x's. But really, no, that's actually not what you're gonna do, because these ones are used for navigation only. These are pretty old ones, all things considered, and you don't really use these anymore, because I mean, like, these would be useful in, say, navigation. If you're on a ship and you're using IB's favorite math problem, the bearings problem. You've seen the thing. You've seen the bearings problem. You got a point. It's pointing up north, and then your ship's going, I don't know, it's going some degrees, and it's at a new point right now, and you've seen the bearings problems, and so knowing these ones would help you out with this. It would also helps you with navigation, and we don't really navigating ships anymore, and we have radar and so much more technologies and we've mapped out the surface of the ocean so much better, so we don't really even need to use these ones anymore. But even some of the ones we do have, like those what are up with the cosecants and all, like what are up with these ones? See here, this is actually why you will hear me not call you. This is why you will not hear me using a sine inverse of theta, because this is kind of confusing given these functions. These functions are what I like to call, these are sort of the these are the reciprocal trig functions essentially. So let me go down here. Sorry about that one. Don't know what to do with that one. Let me just go down here and start out here. So if you've taken a calculus class, you've definitely seen these ones. This is going to be got secant theta is 1 over cosine theta. You've got cosecant theta is 1 over sine theta. And then cotangent theta is 1 over tan theta. Now, these ones in general, you are not even listed on your calculator, and you might be thinking, when would you use these? The answer to when you use these is you use them because they get simpler, because they're just easier to use in calculus problems. Like, for instance, say someone asks you, what's the derivative of tan theta? And you've never done it before. Like, well, you could say tan theta equals sine theta over cos theta. So that means you can just use some good old-fashioned quotient rule here, where it's going to be basically it's going to be the derivative of your upper function. It's going to be good old cosine theta times, well, actually it's going to be minus cos, because you're going to be doing wait, never mind here. I'm sorry, I'm not a real mathematician if I don't do this one. Yeah, your cosine theta at the bottom times the bottom function, that being the, what the devil, times another cosine theta, like minus, well, it's going to be plus, because the derivative of cosine theta is minus sine theta. It's going to be plus sine theta times sine theta. And all over cosine squared theta means that your derivative of tan theta is actually going to be equal to, well, derivative of tan theta is actually going to be equal to, because trig identities tell you it's going to be 1 over cosine squared theta. And you could say the derivative of tan theta is 1 over cosine squared theta, or you could just say the derivative of tan theta is secant squared theta. And yeah, here you might not care, but trust me, if when you're asked to find the derivative of some much more advanced trig problems, yeah, you start thinking here to yourself that man, these are gonna be useful, and really that's their main uses to simplify things here. And actually, some of them there is other reasons why they exist in general, and I want to get into that in a different video. But first, I'd also like to draw your attention to if you do still want to say here that there are really only three functions then, because, I mean, look, I mean, sine theta, they can all just be expressed in the form of sine theta, cos theta, and tan theta. But before, I already showed you that tan theta in general, can be easily discussed as sine theta over cos theta. And in general, don't even need to be using cos theta. Cos theta is just a translation of sine theta. Cos theta can really just be sine of pi over 2 minus theta. So, really, we can really be discussing everything in terms of sine theta. So, you could actually say here that if you want to be technical, you could say that how many trig functions are there? There's only one, because they can all be expressed in the form of sine theta. Now, the reason why we're not all saying here that the tan theta equals, the reason why we're using tan theta and not sine theta over sine of pi over 2 minus theta is because this looks confusing and kind of complicated, and no one wants to deal with that. So we obviously simplify it to cosine theta and tan theta, and hey, that's actually kind of interesting that cosine and sine are related like that. They both have the sine prefix. Root. And what does co mean? But you know what? I kind of want to get into that at another point. There's actually three other trig functions that I think are worth talking about, and it's because I'm biased and because I'm Hindu that I feel like the other three that need to be talked about are jya, kotijya, and finally utkarmaja. Yes, I'm not joking. Now then, this one, you might be thinking here, okay, what the hell is this? And this is actually, and before you're wondering here, these are length-based. In essence, these are length-based. You can actually look these up on Wikipedia, and you'll get like a little image that's gonna look something like this. You're gonna see a little right triangle, then you're gonna get a little, you'll get an image that looks something like this. And then you get like a nice little one like this, and you'll just do like a little arc. And then all it's going to be named, and then you're just going to name them all like M. M, A, O, R, B, and then the arc is going to be S. And then essentially, Jia is going to equal, and Jia is going to be the arc of AB. So basically you're doing these are all going to be in the relation to these trig functions are all in the relation to this arc right here. So essentially you're going to be saying here, so it's basically this arc is going to be equal to BM. Cotijia of the arc AB is going to be equal to oh my OM, and then Utkarmaja is going to be equal to MA. And now, this might seem really complicated, like, why are you doing this? But I like to point out here, the only reason why this seems complicated is because, and the only reason why we don't use this one is because the Greeks or something came up with our good old-fashioned SOHCAHTOA, like, perpendicular sine theta, cos theta rules here. And, because, I'm just going to say it, white people took over the world eventually. we don't use the Hindu symbol. We don't tend to use the Hindu ones. This doesn't really pertain to anything. I just thought it was interesting, and you have to listen to it anyways. Ha. So yeah, that's it. That's the answer to how many trig functions are there. There are several answers. I think that the main answers you're gonna hear is I think you could definitely argue that the argument is definitely going to be that you can use that technically, there's only one sine theta. Most of the time, most high school students, when they start off, are going to be using the 3. And then if you're in calculus, you're going to be using 6, the cosecant, secant, and cotangent. And what about versine, x cosine, x secant, and all? Well, those ones are going to be for people who really, really, really like to be technical and say there are actually 12, and even then, you're dead wrong. There's like 36. I didn't even talk about all of them. You're going to have to look that up on your own time. Maybe I'll make another video about the other 36 trig functions if you're really, really into trig functions, but you know what? For now, I'd say that's all for today. Hope you learned about how many trig functions there are. You can technically say 1, 3, 6, or 30 in Hinduism. Or 12. Or 36, I guess. Good day, guys.